So yesterday we did kind of easy problems. Today we're going to take it up a notch. Now, this right here should look very similar to this problem right here that we did on yesterday's notes. It's not exactly the same, but it's pretty dang close. So I want you to try this problem. Okay, you're going to make a plan, you're going to write Gemma, you're going to make your do and undo list, and then you're going to solve it. This should look very similar to the one from yesterday, so everybody go ahead and take like one song. All right, so I'm going to do my work. Y'all tell me if I did it right. Okay, so I'm writing Gemma. Okay, and then I'm looking for stuff that happened. I don't see any grouping or exponents, but I do see multiplication and addition. So the first thing I see is, now I have had some people over the last couple of days kind of getting confused about multiplication. So they're like, I don't see multiplication. But remember, there's like an invisible multiplication sign in between those two things, right? So this is 3 times y. So this right here is multiplication. And then we added 2x here. So I multiplied by 3, and then I added 2x. Is that what y'all got for your first step? Okay, great. So now, to undo that, I got to go in the opposite direction. So I need to subtract 2x and divide by 3. So let's see if I do this right. So I'm going to subtract 2x. Remember, I cannot combine 12 and 2x. Remember, as we discussed yesterday, which we will never speak of again. All right, exactly. Let's okay. All right. Now, there's 2 different ways I could proceed here, and it just depends on kind of like, it just depends, okay? So the first thing I could do, hold on, let me turn this on so I'll stop yelling. The first thing I could do is I could divide this side by 3 and this side by 3.
This way. Is that?
I don't know. Hold on. Let me see. Okay. And then I divide. Now, does everybody understand why I'm canceling these out? Is it because I'm subtracting? No, it's because 3 divided by 3 is 1, and that's an invisible, so I don't have to write it. So that leaves me with y equals 12 minus 2x over 3. Or I could break those up, right? So I could say 12 divided by 3 is 4. Negative 2 divided by 3 is negative 2/3 x. And I could write it like that. Okay? Now, here's what I want to tell you guys. So, like, also I had some people like, but why would I do this? Most of the time, you're going to see it looking like this. Sometimes you might see it looking like that, but I let the question and the answer choices guide me, okay? If they're asking me for slope, I'm going to write it like this because I can see the slope right here in front of the x. If they're asking me for y-intercept, likewise, I'm going to write it like this. If they're giving me something that looks like this, I'm going to write it like this, or if I need to get it in the calculator, I'm going to write it like this.
But I solved it a different way.
Did you get the same answer as me?
I got x equals negative 3 over 2y plus 6.
Well, yeah, because we were solving for x, not y. You solved for x, not y.
Oh.
So you got x by itself. We were trying to get y by itself. Hey, you know what? But you got x by itself, and you did that right. Go you. Yes, ma'am.
2 over 3.
Because okay, see this whole, hold on, let me kind of circle it in a different color for you. You see this whole part right here? So if I break this up and I do 12 over 3 minus 2x over 3, remember I can rip this x off and just attach it to the side. So I don't have to leave the x up here. I can just kind of like take it off and just stick it right on the fraction bar. And it's negative because there's a minus in between them. So 12 divided by 3 gave me 4. Negative 2x divided by 3, I ripped off the negative 2/3 and put it here and put the x next to it. Not that one. That one you can't because 2/3 does not terminate. So you would get 0.67, which is an estimate. And we don't want that.
So for every problem like that, you just like put the number here and the bottom number there.
Yeah. Yeah, and if it's something like you could, like if it was 1/2, you could put 0.5. That would be fine. But again, I like to leave them as fractions because when I'm graphing lines, this is rise and run. This tells me how to move to the next point on the line, so that's useful for me. Okay? All right, so knowing what you know and looking at the process you just looked at here, what's different about this equation?
It looks funky.
Yeah. But what's different about it?
No number letters.
There's no numbers. It's all letters. But you use the exact same process to solve this one as you do that one. Okay? No, it doesn't equal like W. Okay? Do you guys want to try this one, or do you want me to do it with you? Huh? What? Okay, do y'all want to try it? Okay, how about this? I'll give y'all a 1 minute head start, and then I'll come in and start doing my work. Y'all can tell me if I'm doing it right. Okay, it says solve for y. So that means the variable I'm trying to isolate is y. And that's, again, a reason why it's good to highlight one of them. If you need a highlighter, I got a whole drawer full of them. I'll be the judge of that. Wow. Tough crowd, okay. Or this.
Oh, I got AX for C on the B. See, I mixed them up though.
You know why? Because right here, you saw AX, you didn't subtract it. You added it. Okay, settle down. We're on the internet. Okay. All right, take a look at this. Okay, so again, you guys are kind of freaking out here a little bit, but look. This is the exact same process that we use for this. I mean, look. We multiplied by 3, we added 2x. So instead of multiplying by 3, we multiplied by b. Instead of adding 2x, we added ax. And then we reversed it. Now, question. How many of you are kind of freaking out about this because you're like, okay, now what? Now you circle it and you move on to the next question because you're done. Is y by itself?
Yeah.
Then I'm done. There's nothing else to do. Okay, once I get y by itself, I'm done. There's nothing else to do. I don't have anything else to work, because this is the goal. The goal is, again, remember, we're not getting a single number anymore. Now we're kind of rearranging, we're manipulating the equation. Okay? All right, just for a second, I want you to pause, I want you to talk to each other, and I want you to think about what questions you have so far.
How do you subtract the letters?
Okay, and that's another question. That's another question I've been getting a lot today. Like, why are we using letters? Why is everything?
It's not like why are we? It's just like.
Okay, well, this actually goes to that question. So, why are we subtracting letters? Okay, so listen, guys, give me your attention. Okay, so my husband works for a food company. Basically, they sell food to other to restaurants, and they sell supplies to restaurants. And so what he does is he does reporting. And so they have all these trucks, and they have different routes that they take to get places, right? And so maybe they're all going to the same place. And so his job is to check and see, do I need to use 3 trucks to do this? Can I have this truck like kind of take a little detour here, and would it end up being cheaper? Okay? So when he writes reports, and what he does is he says, okay, I've got route 1, I've got route 2, and I've got route 3. And that equals this much load. Now, Do you think those routes are going to have the exact same weight of stuff on them every time? No, they're going to be different because, right, the real world isn't the same all the time. Do you know what it means when things can change? Do you know what that's called? When things aren't always the same value? It's called variability. It means they're variable. These things are called variables. And the reason why we're using them is because maybe they're giving me an equation. Like, okay, so here's an example. Like, one of the problems on your homework was, I think it was V equals pi r squared h, and they said write it in terms of height. And people are like, why would I do that? Well, what if all I knew was the height of this thing, and what if I knew the volume and the radius, but I didn't know how tall it was? I could use that information, and I could use that and figure out what the height was using the information I had. Okay? So that's what it is. That's why we're doing this, because sometimes we don't have the same information, and these things are variable. They're not the same every time. Okay? So, let's look at this guy.
But my question was more like
How can I subtract a number?
no. It's just like every time is it just going to be written out like one letter minus another letter?
It might be, yeah. We're just going to have weird looking stuff like this from now on.
I know, but I'm asking, is that always how you're going to write it?
Yes. Yeah. Yeah. Okay, so real quick, tell me some ways that you might solve this, something that you can think of that you might use to solve this. Yes, ma'am. Wait, what? So you would like do cross, like the butterfly thing?
Yeah.
The butterfly thing?
Yeah.
Like, so you multiply these two together and you multiply those two together? Anybody else got something else? Because, yeah, that's definitely one way. Anybody else have a different way they'd try it?
Yeah, something, Margot. Say something, Margot.
Oh, my God. Wow, it's a violent atmosphere in here. Seventh period is, they don't play. Yes?
So on this one, what if we multiply?
Yes.
Multiply
Okay, so I'm hearing y'all say a lot of cross products. So let me ask you a question. What if it was like this? We don't like fractions, right? Because they're kind of the worst, right? How do we get rid of fractions?
Well, we multiply.
By what?
By
By the common denominator. Great. What's the common denominator here?
I don't know.
D.
No?
No, it's both.
What is it? It's MD, right? Because if you don't know what the common denominator is, right, you just multiply them together. So the common denominator is MD. So I'm going to multiply this by MD and that by MD. Yeah, KMD over M equals FMD over M. I'm sorry, over D. Sorry, that's a D down there.
D.
Grow up.
Jack on the D.
Miss, I got D equals FM over K.
So now what do I do?
What, sinking?
Now that I've got this, what can I do? So what did I do up here when I had the same number? They canceled out, right? Because the top and the bottom is the same. They simplify to 1. Well, is there anything I can cross off here? Yeah, I can cross off these M's.
But I got D equals FM over K. Right?
Okay, hold on. Yeah, we're getting there. And now I can cross off these, and I have FM.
Oh, yeah.
Okay, so now, right, I'm trying to get D by itself.
K over K.
Oh, just
No, stop saying stuff and stop doing stuff. You were on the right track. So what's happening with the K and the D? What's happening to them? What are we doing? We're multiplying, right? So how do I undo that? I divide, and I have D equals FM over K. Is is D by itself?
Yeah.
Great, then you circle it and you're done.
No, it's not.
You're very excited. You got it. I heard you have the right answer, and you're like, no, you do this, and I'm like, don't do anything. You have the right answer. Are you okay? Okay. All right. So what do y'all think about this? Now, you could cross multiply. You could use, you could use cross products. But we're not supposed to teach you, Wolf. We're not supposed to teach you a strategy you don't have the math to understand. Oh my gosh, bless you. Blessings. Hashtag blessings. I'm not supposed to teach you a strategy you don't have the math to do. So some of y'all learned cross multiplication, but I don't think you understand why you're doing it. But if you notice right here, a lot of y'all said you multiply K times D and F times M. Well, hey, take a look what we have right here. K times D equals F times M. So you ended up with cross products, and that's because of common denominator. Okay? All right. So then, I want to talk about one thing real quick before we do this problem, okay? Unfortunately, so one of the problems that we have, there was a problem. Oh my gosh, it's on the assignment. Hold on a second. It's not on this. It looks like this. E over little e equals big R plus little r over r. Okay, so do you guys see this? What do you think you can do with this? What does it look like you can do?
Simplify.
So does it look like you can simplify? Does it look like you can simplify these two?
And letters, they look.
But does it look like you can...
Because they're not the same.
Exactly. Okay, so that's something you have to know. In math, a big E and a little e aren't the same thing. So do y'all remember when y'all did, you may not, when y'all did volume, and you had the big B, which was the area of the base? Okay? And do y'all remember how the little b was the base of a 2D figure? So like that was the base of a triangle or the base of a trapezoid. And the big B was the base of a prism. These are not the same thing. They are, one's capital and the other one isn't. So case matters too. If I have something, this E and that E are not the same variable. They're different variables. So case matters. All right, so just keep that in mind. Now, here's another problem, okay? I want to show you this real quick, okay? If I have this and that, don't those look pretty dang similar?
Yeah.
Do they? Don't these look the same, though? Don't they look very similar? So yes, they do. What are you talking about? You don't even know which one's the T because you're wrong. That's plus TF, right? Exactly. Right. So when you write letters in algebra, when I was a kid and they told us to write letters for algebra, they told us to write them in cursive. But at the very least, you need to write them in, try to write them in italics, okay? So when I draw a T, I do it like that, kind of curvy. When I do like an F, it looks like a freaking mermaid, okay? When I'm doing equations, I make them as curly as can be. And even there's one of these questions where I had to put a 1 in front of something, and I was like, that looks like an L. So I never make my 1s like that, but dang, when I got something when it makes it look like an L, you know I'm going to do it. So you need to make sure that when you're using letters and numbers, you differentiate them as much as possible. So take a look at this guy down here. We got T's, F's, and that's an O. That is not a 0. That's an O. Okay? So let's think this through. The first step before we even get to Gemma is always to get rid of that denominator. How do I get rid of the denominator? Multiply by what? The common what? The common denominator. What is the common denominator? The only denominator, O. So we're going to multiply everything by that. Okay? Huh? Because you kind of treat this like it's in parentheses. So what that ends up looking like, it looks like O times G equals O times T minus F over O, and write these two O's cancel. Do y'all see that? Oh, that's nuts, right? Okay, so now that I've got this, now I need to Gemma this, okay? So first of all, I'm going to tell you something I don't like. I don't like when the variable I'm trying to isolate is at the end, is at the back, it's being subtracted. So immediately, I'm going to rewrite this so that I'm going to give it a coefficient, right? Okay, do y'all see how I rewrote that? I just flipped them. Notice, remember, this negative here is part of 1F. And I'm not going to lie to you, that looks like LF, so I'm going to make it look like a 1. Okay? Do y'all see what I did there? I just did that because when I'm looking for what happened, it feels more natural to go from left to right. Okay, so, what is the first thing I did to this F? What happened here? I multiplied it by -1. You could have also say I flipped the sign, right? Because it's the opposite of F. You could do that, but let's not even go there. What else? What's the next thing I did? I added T. So how am I going to undo that? I'm going to subtract T. And then what am I going to do? Divide by -1. Do y'all agree with him? Does he speak for you all? I mean, he's right, but do y'all understand what he's saying? No? Yes? Are you awake? I mean, we still have like... I'm just undoing it, yeah. Okay. So, I'm just going to rewrite this over here. I have OG equals -1F plus T. So I subtract T from both sides. I have OG what? I have OG what? OG minus T equals -1F. Notice how the room got real quiet? All of a sudden now y'all ain't got nothing to say, huh? Okay, and now I divide by -1. Okay, well, 1 OG divided by -1 is negative OG. Negative T divided by -1 is plus T. -1 divided 1F divided by -1 is F. Is F by itself? Then that is the answer. How about that nonsense, y'all? Yeah, I know. I sense, but this is happening. This is happening. Okay, so I'm going to post this so that if y'all need to rewatch this, you can. Do y'all have any questions that you might like re-asked later? Y'all got any questions about this? Yeah, it's recording right now. That's why I've been yelling at y'all the whole time. Is it a question about math? Okay.
Why are they making us solve an equation without equation?
I don't know. All right, good luck.